Welcome to lesson 2-7. So we're going to apply all the stuff that we did the past two lessons with the families of functions. We're going to now put that into application to graph absolute value functions. So absolute value functions take the form f of x or y equals absolute value of x, and it ends up creating a V shape. Now, it is symmetric about a vertical line called the axis of symmetry. And it has a maximum or minimum point that we call the vertex. So here's the basic idea of where it's coming from, all right? So this is a table representing its values. So notice all you're basically doing is wiping off the sign of the x. So whether x is negative or positive, you end up getting a positive value. And that's where the V shape is coming from. The axis, or I'm going to start with the vertex. So the vertex is where that minimum point is, where the bottom or top of the V is. That is going to be the vertex. So in this case, for the basic one, the vertex is at 0, 0. The line of symmetry is the line that goes through the x value of the vertex. So for that basic one, the axis of symmetry is at the x, all right? Or is at x is 0. So what you want to do is you want to make a table of that parent function. Well, the cool thing is that table is going to be the same, all right? And it's relatively easy to make. Then if there's a stretch, compression, or x-axis reflection, you make a new column performing that transformation. You graph that transformation and then perform any translations from there. So again, those strategies probably seem really wordy, but again, once we dive in, you don't really have to worry about the wordiness of it. That's just if you forget the steps that you can reflect back on it. So let's take a look at this. So we want to graph that function. So all I see are translations. A translation 2 to the right and 3 up. But I'm going to start with my x and y. So again, the table is really easy to make, all right? All you have to do is put in values, wipe off the signs from them. So this is what that parent function looks like. But then what's happening? Well, what's happening is this being shifted to right and 3 up. So what I'm going to do is I'm going to take every one of those points and I'm going to do that transformation. So I'm going to start with the vertex, 2 to the right and 3 up. So there's my new vertex. Then 2 right, 3 up. There's my next point, 2 right, 3 up, 2 right, 3 up, 2 right, 3 up. So that green represents the actual graph that I'm looking for. And all you have to do is understand the original, and then you're just going to shift it. So in this case, we shifted it 2 to the right, 3 up, and that gave us our new graph. So the vertex, again, the vertex shifted 2 to the right and 3 up. So that's how you find the vertex. Is again, you just look at those translations, and that basically hands you the vertex. The axis of symmetry is always the vertical line that goes through the x value of that vertex. All right, what about this one? Well, if we're graphing the parent function, it always starts exactly the same, all right? So there's my parent function. And now let's see what's happening to it. Well, here I see it's being shifted left 4. Again, horizontal works opposite of what you'd expect. And then down 1 because of that. So now I'm going to perform that operation, those transformations. So left 4, 1, 2, 3, 1, 2, 3, 4, down 1, puts my vertex right there. Left 4, down 1, left 4, down 1, left 4, down 1, left 4, down 1. So again, you're just taking those points and shifting them each to get your new graph, okay? So the graph you want is the one that's in the green. Okay, that's the one that you really, really want. So its vertex, well, its vertex shifted 4 to the left and down 1. And then its axis of symmetry is always the line through the x value of the vertex. So my axis of symmetry would be the line x equals -4, because you know that is the vertical line that goes through there. So that's the basics of this graphing. In terms of translations, well, more than just translations can happen. So what if I gave you something like this? So we start with our basics still, with x, an absolute value of x. But now we have that shifting or that stretch, right? So I'm going to add another column where I take that stretch into account. So I'm going to take each of these values and multiply them by 2. So now I really don't even need this middle column anymore. I'm going to scratch that out because what I'm going to plot is x and y. I'm going to plot those on my graph. And then from there, that is what I'm going to shift. So 0, 0, 1, 2, 2, 4, and then -1, 2, -2, 4, and then so on and so forth. So there's my graph that takes into account my shift, or my stretch, all right? So that takes into account that stretch. Now we have to look for the shifting that's happening. Well, if you look right there, horizontally, what's happening? Well, a minus for horizontal means it's going to the right. And then this minus right here at the end means it's going down 4. So let's actually perform that. So right 1, down 4, 1, 2, 3, 4. Right 1, down 4, 1, 2, 3, 4. Starting here, right 1, down 4, 1, 2, 3, 4. Right 1, down 4, right 1, down 4. So this is the graph that you're going to get. All right, and again, you deal with the stretch inside the table, plot it, and then you shift it around to create that absolute value function. the vertex was moved to the right 1 and then down 4. And again, as always, that axis of symmetry is the line, the vertical line, that goes through the x value of the vertex. All right. So let's take a look at this one. So this one is even a little bit more unique. So we're going to have our x and the absolute value of x, just like always. But now take a look at what's happening. So here, now I want to incorporate -3 times that middle column. So again, you always want to incorporate any stretches and reflections into a new column. So I'm going to take all of these and I want to multiply them by -3. So I can essentially just wipe out that middle column. Now I don't need that because these are going to be my x's, these are going to be the y's that I'm plotting. So start with 0, 0, then 1, -3, 2, -6, -1, -3, -2, -6. So that's my estimate value function, taking into account the x-axis reflection and the stretch. Now I want to shift it. All right, so let's take a look at how it's shifting. Well, horizontally, we see that +2, a plus there means left. Vertically, we're looking for just what we would expect, up 5. So let's do that. Let's start with the vertex. Left 2, up 5. 1, 2, 3, 4, 5. So there's my point. Let's take this one, left 2, up 5. 1, 2, 3, 4, 5. Same thing here, left 2, up 5. Left 2, up 5. Left 2, up 5. So here, now that we have those couple points, there is our new shape, our new function. So again, let's take the vertex. I'm going to shift it 2 to the left and up 5. And then the axis of symmetry. Oh, the axis of symmetry, the line that goes through that x value of the vertex. All right. So one last graphing example. So when you're graphing, sometimes you can see something that looks like this. This doesn't look quite like what we just did. All right? We're not used to it looking like that. So what you actually have to do in this case, you can factor 2 out of that inside. So if everything on that inside is multiplied by a number, you can just factor that out, and now you don't have to worry about that number. Now that number just became your vertical stretch. All right, and from there, you can do everything exactly the same as what we've been doing. You set up your table. I see that I have a stretch of 2, so I'm going to have a third column in my table where I take that into account. So I'm going to take all these values and multiply them by 2. So now I don't even need that column anymore. Now I can just use this. All right. So I can use these as my x's, these for my y's. So I'm going to plot those values. And again, since it's a line, it will extend so you can be as accurate as possible in your graphing. So that's what the original stretch looks like. Now from that stretch, now we can look to see what else is happening. So here, see a vertical shift, 2 to the left, because horizontally, a positive means left. Then the vertical works the way that you think it should. That means you're going 3 down. So let's plot that vertex. So 2 to the left, 3 down, puts me right there. And then you can just plot your new graph, that green graph. And the vertex again follows the shifting, so 2 to the left, 3 down. Axis of symmetry always goes through the x value. All right, we're nearly done. Just one more little concept that I want to cover. You can actually find the equation of these absolute values. All right, so the first step is you can find the vertex. Because that vertex, so in this case, -1, 4, that vertex will show you the translations. The slope. So here you have -1, 3. So rise of -1, run of 3. So you probably even picked up on this. You probably even noticed this, that the vertical stretch basically was identifying slope for you. All right, so just a little trick of the trade for these absolute values. That slope is a version of a vertical stretch. And from there, you can actually write the equation. You take that stretch, that slope, is shifted 1 to the left. Well, left takes the x, but you write it oppositely of what you'd expect, and then up 4. So that's just a really quick way that you can look at a graph and then go backwards to the equation that made it. All right, well that's going to be all for our notes today. So as always, thank you for joining me for this. Make sure you take a little bit of time, write that summary for me, and then come back ready to do your practice work.